Hello, and tonight in Lesson 1-7, we're going to look at inductive reasoning. But first, our objectives. Our first objective is that we're going to be able to write rules for patterns. And our second objective is that we're going to be able to make predictions and test conjectures. Now, to begin, I have a term for us, and it's called inductive reasoning. And that's when you make a conclusion based on patterns that you observe or you see in nature. For example, I have this one with 3 different dice down here, and you'll notice the red spot is basically moving. All right, that's what do you observe? Well, the red dot is moving. Now, I want you to take a moment and think, how is it moving? And write that below. Go ahead and pause me now for that. All right, so as I said, the red dot was moving, but you had to tell how it was exactly moving. And here it looks like it's moving downwards. So it goes over, then up, and so on. That's what I assume it's going to do. Now, when you make predictions, that outcome you come to, or that conclusion, is called a conjecture. Again, that's just a conclusion you reach by using this inductive reasoning. For example, there was the red die one. So what comes next? If I wanted to show what comes next and write it in words, I'd do it below. So go ahead and tell me, or really draw it out, where you think the red dot is going to be here. And then write your conjecture in words. I'm going to pause well, why don't you pause me, I should say. And then when you're done, come back and let's see what we have. All right. Now, my conclusion, based on the pattern I see, as I said, it looks like from this one to this one, it goes down. It went from the top left-hand corner to the bottom left-hand corner here. Then it looks like it moved to the bottom right-hand corner. So I'm going to assume the next place it's going to go is this top right-hand corner. So that's what I would say would come next, and now I have to write it in words. The red circle will be in the top right-hand corner on the die. All right, so that is my conjecture, both with the picture and words. Now, something I do want to stress to you is just because you make a conjecture or you come to a conclusion, it doesn't always mean it's right. Maybe in this one, they're not going to have the dot in the next, or the top right-hand corner. Maybe they're going to switch back to the beginning and do the top left-hand corner. You don't know. We're just assuming, really. We're making a prediction, and predictions are not always right. For example, you will hear a lot of the times, if the light is on, someone is home. Well, that is a conjecture. The light's on, well, someone must be home. And I know for a fact that is not true, because last night I left for Mankato, and when I came home, I left my bedroom light on. So I'm a little afraid of my next electricity bill, but yeah, I guess it's all in the ways of math. All right, so we have this next example, and it says make a conjecture about the next figure in the pattern below. So we have to conclude, make a conclusion, and then draw a picture. So really, they want us to write something again, and then draw a picture. Now, so if you take a look here, we go from 1 red dot to 4 to 8 to 12. Now, if you take a look at these, how do they change? What's happening each time? All right, so if I were to look at this, I notice there's 1 dot. And here on the second one, well, there's 2 dots on the bottom, 2 on side, and so on. So there's 1, 2 on each side here. On this one, there's 3 on each side. And on this one, there's 4 on each side. So I'm going to assume the next figure will have sides of 5 and have, well, I'll draw the picture to find out how many dots. So right now I'm writing blank dots. So I'm going to go ahead and do this. So I need 5 on each side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if I count this out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It'll have 16 dots. That is my conjecture, both with pictures and words. All right, now, number 2, we just did that with a picture. Now they want us to do this with numbers. So they want us to find the rule. What's happening every single time to get to that next number? Sometimes you're adding, sometimes you might subtract. You could multiply, you could divide. You could even multiply and add at the same time. So, what I would like us to do here is, well, let's do A together, then I'm going to have you try to do B and C on your own. So A, we have 0, -4, -8, -12. Now again, I need to find out what is happening each time to get to that next number. Now, if it doesn't work for even one number, it's not the rule. So here, the only way to go from 0 to -4 is to subtract 4. Let's see if this works for the next number. -4 minus 4. Well, if you have -4 and you take away 4, oops, don't want to write that there, you do end up with -8, so you subtract 4. -8, well, -8 minus 4 would bring me to -12. It looks like it works for each number, so I need to write a rule. And here's how you write them. You say start with, so tell me what number you started with. Here I started with 0, then subtract 4 each time. That would be considered my rule. I started with 0, and then I subtract 4. It's important to tell what number you start with because we need to know if, well, if I brought this up to you and said, find the pattern here. You start with 0, and I need you to subtract 4 each time. You should be able to do that. You should be able to have all the right numbers starting with 0. If I don't tell you what number to start with, you might start at 100, somebody else might start at 50, somebody else might start at -10. So it's important to tell that starting point. All right, so now you have to do B and C. If you'll pause me now, you'll get to start. Go ahead. All right, let's check your answers. Now B, it goes 4, -4, 4, -4. Well, for this one, it looks like you basically just go back and forth from 4 to -4. So here you should have something similar to start with 4. Then, let's see, alternate would be a good word. Between -4. So you start with 4, then you do -4, 4, -4, and so on. All right, now C is actually a very tricky one. It's very, very tricky because it goes 1, 2, 4, 8, 10. Now here you might have tried to add 1 each time. Well, that doesn't work when you get to here. Then you might have tried to times by 2, which works at the beginning. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Well, 8 times 2 is not 10. So that one doesn't work. Instead, this one, what they end up doing is here, you would times by 2. All right, but then from 2 to 4, what's another way we can go from 2 to 4 without timesing? Well, that would be adding. So here they did 2 plus 2 is 4. Now here, 4 and 8, well, 4 times 2 gives me 8. And then here from 8 to 10, you add 2. So here, you start with 1, then times the next number by 2, then add 2 to the number after. And I'm running out of space. There we go. And maybe alternate. So somewhere along that lines, and it's okay if you didn't get C, because like I said, that one was very tough. It would have taken you some time maybe to see it. Or if you did notice it right away, good for you. You got a really tough one. You deserve a pat on the back. All right, now our third example, we're just pushing this further and further each time. First, we looked at patterns and said what was happening. Second, we wrote patterns with numbers. Now, third here, we're going to extend the pattern. So we're going to say or predict, make a conjecture, that's that term again, about what's going to come next. So number 3 here, write a rule for the number pattern, 110, 100, 90, 80, and so on. Find the next 2 numbers in the pattern. So here they're asking us to do 2 things. First, they are asking us to write a rule. Write the rule, start with this number, and then tell what you do. And then tell me the next 2 numbers in this pattern. So if I were to start here, well, I know I'm starting with 110. And now I have to find out what happens each time. Well, to go from 110 to 100, I'm subtracting 10, subtract 10, and so on. So you're going to subtract 10. And in fact, I might actually add and in there. So start with 110 and then subtract 10 each time. There we go. I wrote my rule. Now I need to tell the next 2 numbers. So if I have 80 and I subtract 10, well, my next number is 70. And again, if I do that, take 70, subtract 10, I have 60. This would be my answer. All right, now we're going to look at making predictions and counterexamples. Because as I said, sometimes we can make a conjecture and they're not always right. There are times when they're not. So we're going to look specifically at counterexamples, excuse me. So here, number 4, you toss a coin 4 times and it comes up heads every single time. Is the conjecture the coin will come up heads on every toss reasonable? So you have a quarter. And the last 4 times you got heads. You got heads, then you flipped it again, you got heads, you got heads, you got heads. So they're saying, oh, no matter what, you're always going to get heads. And you have to decide, is that true? Is that reasonable to say? Well, I have here a little activity, and I can do it. I can start and then stop. Well, I got heads, so that time it was true. That time it was true. It's true, but this 4th time, I got tails. So is it always going to come up with heads? No. You can get tails. So when I tossed this coin and showed that I could get tails, that proved that that conjecture is not always true. So, number 5 here, this 5th example, you need to decide, is each conjecture right or wrong? Now, here's the thing. If there is even one possibility, one thing that proves it wrong, it's not true. All right, just like the heads and tails. It doesn't matter how many times head would have popped up. If I got tails just once, it makes that conjecture wrong. So A here, every triangle has 3 sides of equal lengths. Is that true or false? Does every triangle have to have the same sides? If it's right, say yes or correct. If it's wrong, give an example of when it's not. So here, I could draw a triangle, and I could have one where it's an equilateral, all the same sides. However, a triangle is made up of 3 sides. That's what I know. Do all the sides have to be the same length? No. For example, here's one. This side is smaller than this side, is smaller than this side. So this is incorrect. And I just showed basically with the right triangle. Now, you could draw a picture or you could write it out, or you could do both like I did. It's entirely up to you. Now I want you to look at B and solve that on your own. The opposite of a number is negative. Go ahead and solve that, and when you're done, let's see if you got it right. All right, so the opposite of a number is negative. Let's see, if I did 3 and asked for the opposite of that, that is negative 3. 2, well, negative 2. Let's see, 1, negative 1. So for all those numbers, that is true. But is there any number that it's not true? And if you take a look, there are. What if I start with a negative number? If I started with a negative 6, the opposite of that would be a positive 6. My answer here is not negative, so I know for a fact that this is incorrect. And I could use the example of negative 6 to 6, or 0 itself. There is no, 0 is considered neither positive or negative, so 0 is just 0. So it's negative 6 or 0 are both examples of when this is not true. Again, you might not have chosen the same numbers that I did. Maybe you chose negative 8 or negative 1. Same idea. As long as you come up with one number it doesn't work for, that conjecture is incorrect. Now, we have our little quick check here just to end our lesson, and then from there you'll be done for the night. So, let's see here. Why don't you do 1, 2, and 3, and then when you're all done, just check your answers and we'll be done. Go ahead and pause me now. All right, so for 1 here, we go 1, negative 1, 2, negative 2, 3, and so on. Here, if you take a look, I'm going to just say the rule. It looks like when I start with 1, I do the opposite of that number next. Then I move to the next. So the opposite of 1 is negative 1. Then I go to 2. The opposite of 2 is negative 2, and so on. So my next number should be negative 3. And then, I move to 4, then negative 4. Those should be the next 3 numbers. For 2, it goes 1, 3, 7, 15, 31. Again, this is a trickier one because there's actually 2 things you do each time. Now, you can't say you add 2, and then you add 4, and then you add 8, and so on. That doesn't quite work. All right. What I do notice, though, is I times this by 2. 1 times 2 is 2, and then I add 1. And then 3 times 2 is 6, plus 1 is 7. 7 times 2 plus 1 is 15. 15 times 2 is 30, plus 1 is 31. 31 times 2 is 62, plus 1 is 63. 63 times 2 is 126, plus 1 is 127. 127 times 2, well, let's double check on that one. 7 times 2 is 14. Oops, I don't need that. 254, but plus 1 is 255. So that's what you should have had for number 2. And maybe you noticed a different pattern. Maybe you saw it a different way. As long as you got the same numbers, it works. Then 3, negative 11, negative 8, negative 5, negative 2. On this one, we're going to be adding 3 each time. So negative 2 plus 3 is 1. Then it's 4, and then it's 7. All right, that is lesson 1-1. Have a good night.